So variations. In the previous one, I discussed direct proportion in great detail. We'd done some past paper questions. I'd explained the two most common methods for solving this sort of question. And I'd also explained the type of relationship direct proportion is. By name, it's a direct proportion. This topic is included both in IGCSE and GCSE O-level mathematics of the Cambridge International Examinations Board. And so both boards actually have this in their syllabus. If you haven't so done direct proportion, you should probably watch that video first and then go on to inverse. It's easier that way. So inverse proportion, by name, suggests that there is an inverse relationship. Direct proportion was a direct relationship. Inverse proportion is an inverse relationship. It's an opposite relationship. I'd given the example in direct proportion that if one variable, say x, the number of trees planted, increases, the other variable, the amount of oxygen released, increases, y. An increase in x causes an increase in y, and if there is an increase in y, having assumed all the other changes in the environment are constant, an increase in y can be interpreted as an increase in x as well. So a decrease in x is going to cause a decrease in y, and a decrease in y can be interpreted as a decrease in x. In inverse proportion, it's opposite. An increase in x would cause a decrease in y. An increase in the first variable would cause a decrease in the other. A decrease in y can be interpreted as an increase in x, and vice versa. Say a decrease in x would cause an increase in y, and an increase in y could be interpreted as an increase in x. A decrease in x. To make this a little bit more visual maybe, or really tap into your knowledge, is the example that I like to give. Say you have a water tank, and the first variable, x, represents the number of taps with flowing water, and y is the time taken to fill the tank. Pause this video and think, if I increase the number of taps, that is x, if I increase x, would y decrease or increase? See, y is the time taken to fill the tank. So more taps are going to take less time to fill the tank, or more taps are going to take more time to fill the tank. If you said less, you're correct. This is inverse relationship after all. If you have more taps with flowing water, the tank is going to be obviously filled up much faster. So there is an inverse relationship between these two variables. But we saw in the previous video that this sign between two variables represents a direct proportion. So how do you think we can represent inverse proportion? Well, if x is inversely related to y, don't you think x is going to have a direct proportion with the reciprocal of y? The reciprocal of y is essentially y flipped down. So if there's an increase in x, there's going to be a decrease in y. Right here. Let's say initially there were 3 taps flowing into the tank. X was equal to 3. And the time taken to fill the tank, could be anything, maybe 5 minutes. It's obviously a hypothetical example. So 3 taps in 5 minutes. If I increase the number of taps, say 5, maybe it's possible that the time decreases, say 3 minutes now, or 2.5 minutes now. So when x is increasing, y is decreasing. say x is directly proportional to the reciprocal of y, the opposite of direct proportion. Now that you know what a reciprocal is, we can actually move on to the questions. And in the objective, they've given an example question related to inverse proportion. In the previous one, I'd actually converted that to direct proportion just to suit the video. But in this one, it actually is going to be exactly as it is. So I'm going to copy this question down. So here it says, y is inversely proportional to the square of x. The square of x is x squared. So we're just going to treat x squared as the second variable. Given that y equals 2 when x equals 6, find the value of y when x equals 2. Usually, if you're doing a paper 1 question, they're going to give you 2 parts, but this is a very direct question, no pun intended. This is a very direct question, and in this one, they're just asking you to find the unknown variable, when the first step, and usually the first part, is actually deriving the formula. So we're going to do that first. So y is inversely proportional to the square of x, given that y equals 2 when x equals 6. Now, first of all, we're going to make clear the relationship. Y is inversely proportional to the square of x, so y is directly proportional to the reciprocal of x squared. That's going to be y is directly proportional to 1 over x squared. And as in direct proportion, we assumed that in this case, x square root of x is a multiple of y, and k is actually the factor of y, or k multiplies with x, the square root of x to make y. We're going to assume here that y equals k times the reciprocal of x squared. So y equals k times the reciprocal of x squared. And here they've given the value of y as 2, so I'm going to just write 2 right here. K is going to stay as it is, as we're finding this third variable that I've put into the mix. If you find this variable and it's 1, that means that y is exactly, x squared is exactly inversely proportional to y, with 1 as its multiple. And in this case, in most cases, k is not 1, so we're going to find k and actually write down the formula. X is 6, so 2k over 6 squared, k over 36. And that is further going to be 2 into 36 to give us k. So k equals 78, if I'm not wrong. I'm going to write this into the formula. We're not done yet. We have to derive the formula. So, placed 78, k equals 78, into this formula, the general form of an inversely proportional relationship, and I've gotten y equals 78 over x squared. That is our answer for the formula. But it's not the answer to the question. The question is more direct. The question further on says, the question further on says, find the value of y when x equals 2. So we're just going to take this formula right here, y equals 78 over x squared, and we're going to take this known variable right here, x equals 2, going to place x equals 2 squared right here, and then we're going to find our y, which is our unknown variable. So 78 over 2 squared is going to give us it's going to give us 19.5, if I'm not wrong. So that is our answer for this question. Now let's do some practice questions from the past papers. So in this question that I've already solved, y is inversely proportional to x. Given that y equals 250 when x equals 4, find y when x equals 80. I have derived that, y is directly proportional to the reciprocal of x. That means y equals k over x. Then I have put in the situation right here, and I've found k to be 1,000. And then further on, I found the unknown using this to be 12.5 as y. Let's move on to the next one. I would recommend that you actually try solving this yourself and then come back to me to check your answers. Here I have just derived the formula, and using the principle behind inverse relationships, I have derived the formula to be 12 over x squared, and then find the values of x when x equals 3. Substitute and come back to me. Okay, this one has the answer plus and minus 2. Why? Because once we substitute 3 equals 12 over x squared, and they're saying us to find x, we actually have to remove the square. So by taking a square root on both sides, we can find out square root of x equals plus minus 2. So that is the answer. Towards the end of the video, hence, if you have some problems related to this topic that you couldn't solve yourself, please pop them down in the comments below. Any questions, any queries, any papers on request that you guys want me to solve, I'll also be accommodating that. So yeah, with that, I'll see you with another topic, another lecture. Bye-bye.